Hi to all, this is Srinivas and today's topic is electric dipole. If you will get any doubt, you can contact me. My mobile number 9963817138. Another number 8309833096. Now today's topic is electric dipole. Now what is electric dipole? Electric dipole means if two equal and opposite charges separated by certain fixed distance is called as electric dipole. Dipole, di matlab two poles, two charges. Okay, if two equal and opposite charges, two equal and opposite charges separated by certain distance, this arrangement is called as electric dipole. Okay, equal and opposite charges. For example, this is a minus q charge and the next one is this is plus q charge. These two charges are equal in magnitude q, but opposite in direction. And now this is said to be dipole. This is a dipole and this is an electric dipole. This is an electric dipole. And if this is considered center point of dipole, and the centers say the distance of the first charge plus q charge is L and minus q charge is also L, and now this 2L is said to be dipole length. What is 2L at here? Dipole length or length of dipole. This we will take it as a vector. Its direction is from minus q to plus q direction, just like displacement vector. Okay, its direction is minus q to plus q. And now I want to give this is about dipole, which will act as a dipole. Equal and opposite charges कहाँ होता है? Then for example, if you take any atom, in that positive charge will be there, negative charge is there. If you take any molecule, okay, for example water molecule or HCl molecule, in that the total positive charge is concentrated at one point and the total negative charge is concentrated at some other point, and there is some, this is the plus q charge, this is minus q charge. In whole, this is a water molecule or HCl molecule, the whole negative charge is concentrated at one point and whole positive charge concentrated at one other point. There is certain separation between the negative and positive charge, and now this water molecule will act as electric dipole, and this HCl is also act as electric dipole. Electric dipole means there are two equal and opposite charges separated by certain fixed distance. Now the next one is electric dipole moment. What is electric dipole moment? Electric dipole moment, this is our topic. Electric dipole moment, and it is denoted with P. It is a vector. Okay, electric dipole moment is a vector. P bar. What is electric dipole moment? And electric dipole moment means it is the product of magnitude of charge and distance between two charges or the length of the dipole. Distance between two charges is nothing but length of dipole. or we can write directly the product of magnitude of charge and dipole length. Dipole length is called as dipole moment. Dipole moment. Then how to write the formula for the dipole moment? Dipole moment is equal to, what is dipole moment? Is it a P bar? P bar. Dipole moment is equal to product of what? Magnitude of charge and dipole length. What is dipole length? The distance between the two charges in the dipole. What is dipole? Two equal and opposite charges gives the dipole. And this dipole moment is P bar. It is equal to product of magnitude of charge into dipole length. And this simply in magnitude form we write as P is equal to Q into 2L. This is the formula for dipole moment. And now dipole moment is a vector. What is its SI unit? SI unit of dipole moment is coulomb meter. And dipole moment, charge into length. Charge is coulomb and length is meter. What is length at here? This is minus Q charge and this is plus Q charge. And two equal and opposite charges separated by certain distance. These two are opposite charges minus Q plus Q. They are separated by certain distance. The distance between the two charges is said to be dipole length and dipole length is 2L. And now the direction of the dipole moment I want. Direction of dipole moment P bar. Okay, that is from minus Q2 plus Q. Minus Q2 plus Q. The P bar direction is from minus Q2 plus Q. Okay, this is electric dipole moment and its direction. Now till now we discussed what is electric dipole and what is electric dipole moment and what is the direction of the electric dipole moment. And the next topic is and how to find out the electric field intensity due to the dipole. This is very important topic. Okay, and now first electric field intensity on axial line of dipole. Electric field intensity on axial line of dipole. Axial line of electric dipole. Electric dipole. Where we want to find out the electric field intensity. Electric field intensity is what? E. That E we want to find out on the axial line of electric dipole. Okay, and for that let us take the electric dipole. This is minus Q charge and this is plus Q charge, and now this is A and this is B and now this is C. Okay, and now this distance is L and this distance is L, and we want the distance, we want electric field at a point on the axial line. What is axial line? What is axial line? Axial line is the line passing through the two charges. Is the line that is passing through the two charges. This line is called as axial line. This is axial line. And on the axial line at point P we want to find out the electric field. For that, how to find out? Let us take from center to point P, distance we will take as R. Okay, from the center of electric dipole at a distance R at point P I want to determine E. Electric field is there at point P due to minus Q charge. Electric field is there at point P due to plus Q charge also. Now what is the electric field intensity due to minus Q charge? And now what is the direction? We know due to negative charge electric field is towards negative charge, and due to positive charge electric field is away from the positive charge. Already we know this one. And direction of the electric field, that is radially away from positive charge and towards negative charge. Then how to find out here? Electric field due to minus Q charge, left side or right side? Minus Q, towards minus Q. Here electric field is there due to minus q charge, and here electric field is also there due to plus q charge. Electric field due to minus q charge left side will be there, that is towards negative. Electric field due to positive charge plus q away from positive charge, matlab right side will be there. This is E due to plus q charge. Now electric fields are in opposite direction. If we know according to vector rules, if any two vectors are along same direction, we have to find the net electric field, net vector, we have to add them. Same direction means we have to add. Opposite direction net we want to find out means we have to subtract. If they are at certain angle, we have to use the parallelogram law. And here I want the electric field due to plus q charge. Electric field at point P due to what I want? Due to minus q charge. Then how to find out the electric field due to minus q charge? Only magnitude I want to write. Okay, the formula is 1 by 4 pi epsilon naught into q by, now we have to take minus q distance from the point P. Okay, electric field at point P due to minus q charge. What is the distance? AP minus q distance we have to take. Okay, AP square 1 by 4 pi epsilon q by x square is the formula for the electric field. Then AP is what from the figure? That is 1 by 4 pi epsilon naught into q by AP up to center R is there, and this one is L, total R plus L. AP is R plus L whole square, and this is equation 1. And now I want the electric field due to electric field at point P due to minus q charge I want, minus q completed plus q charge I want. Okay, and that is electric field due to plus q charge, E plus q. Its formula is same, 1 by 4 pi epsilon naught into q by its distance. Okay, its distance. I want the plus q charge distance now. Plus q charge distance. Okay, where you want to find out? Electric field at point P due to plus q, matlab plus q distance we have to take. Okay, plus q distance is what at here? We don't know. Up to C R, we can remove this part, we will get this part. Yes, now that means what you will get it here? Plus q distance from point P, this distance I want, that is R minus L, right, from the figure, R minus L. Or if you want write like this is BP square. 1 by 4 pi epsilon q by R square is the formula for E, electric field due to point charge. Previously already we derived the formula for that. 1 by 4 pi epsilon naught into q by, we will get it as R minus L whole square. Okay, from equation 1 and 2, can you tell here plus q is near to the point P, the charge effect is more, that's why here we tell from equation 1 and 2 directly we will tell which is more and which is less. And E due to minus q, okay, it is sum is there in denominator, matlab this one is less, and here less is there and this one is more. Actually plus q charge is at less distance, that's why its electric field is more. That means E due to plus q charge is more. That means E due to plus q charge is more than E due to minus q charge, because plus q charge is at less distance. Less distance means more electric field, because electric field inversely proportional. Electric field due to point charge formula what? 1 by 4 pi epsilon naught q by R square. Matlab if distance is less, electric field is more. Plus q charge distance is less, that's why its electric field is more. Electric field due to plus q charge is more. And now E plus q is more than E minus q, and E plus q and E minus q are in opposite direction. Are in opposite direction. They are in opposite direction. When they are in opposite direction, then how to find out the net electric field? Then to find out the net electric field, what we have to do? We have to net electric field we want to find out. Net electric field at point P. Net electric field at point P. How to find out the net electric field? Then for that, the net electric field On the axial line we will take EA at point P. We have to subtract then, but E plus Q minus E minus Q we have to write why E plus Q is greater than E minus Q. This plus Q is E suffix plus Q. Matlab electric field due to plus Q charge. E suffix minus Q. Matlab electric field due to minus Q charge. And these two equations we have to substitute in that equation, that net electric field E plus Q minus E minus Q. Then what you will get? Let us see. Yes, we got the formula net electric field intensity on the axial line. Formula we got that is E plus Q minus E minus Q. Why we are writing the minus? Because electric fields are in opposite direction. To find out the net electric field, we must subtract. And now here we can substitute the values. Then electric field intensity due to plus Q charge is 1 by 4 pi epsilon naught into Q by E due to plus Q charge is what? R minus L whole square and 1 by 4 pi epsilon naught into Q by R plus L whole square. Now we can common something, that Q by 4 pi epsilon naught is common. Then we will get 1 by R minus L whole square minus 1 by R plus L whole square. And now we can do the LCM, that we will get as R plus L whole square minus R minus L whole square by R minus L whole square into R plus L whole square. Now if we will simplify this, we will get Q by 4 pi epsilon naught into, this one is A plus B whole square, this is A minus B square. If we expand and if we simplify, we will get 4RL, and this is A minus B, A plus B पूरा whole square लिख सकते हैं. Then A minus B into A plus B we will get after simplifying R minus R square, A minus B into A plus B फार्मूला होता है A square minus B square, R square minus L square whole square. And if we change little bit like this, then what you will get? That is electric field intensity on the axial line I will get as 1 by 4 pi epsilon naught into, I will write this 2R outside, the remaining I will write as Q into 2L. I want to change in dipole moment terms, that's why I am writing like this. Okay, if numerator again if you will multiply, Q 4RL is there, Q 2R into 2L 4RL, again Q 4RL you will get, this 4RL I am writing 2R aside and 2L into this Q. Then I will get electric intensity on the axial line as 1 by 4 pi epsilon naught into 2PR by R square minus L square whole square. This is the formula for the electric field intensity on the axial line of electric dipole. How we are writing it here? 1 by 4 pi epsilon, 1 by 4 pi epsilon, 2R, this Q into 2L is P, dipole moment. Dipole moment is the product of charge and dipole length. Q into 2L is P, 2R into P, 2R into P, 2PR. This is the electric field intensity on the axial line of electric dipole. Okay, this is the derivation. And in case of short dipole, short dipole matlab dipole length is very less. In case of short dipole, if this is the dipole minus Q and plus Q, if 2L is the dipole length, I am taking, it is a dipole is a small length, that means I am taking the length L is less than the R, then L can be neglected. Okay, L we can write as 0 when you compare with 0. This R, when you compare with R, L we can write 0. If you write L 0, we will get electric field intensity on the axial line as 1 by 4 pi epsilon naught into 2 pi R by r square minus 0 square. L we write, L is neglected because short dipole. And L is 0 square, r square whole square, r power 4, r power 4. But here r power 4, one r will cancel. Then what you will get the final formula? That is electric field intensity on the axial line. Final formula is 1 by 4 pi epsilon naught into 2p by r cube. This is the electric field intensity on the axial line. I want the direction of the electric field intensity on the axial line. I want the direction of electric intensity. This is for short dipole, this is for any other dipole. I want the direction of the electric field intensity on the axial line of electric dipole. And if you want to find out the direction of EA, what is EA? Electric field intensity on the axial line. And this is minus q charge, and this is plus q charge, and this is dipole length, and the dipole moment is from minus q to plus q. The dipole moment is from minus q to plus q. The dipole moment direction from minus q to plus q. Okay, and now I want the electric field intensity on the axial line. This is axial line. Here I want the direction of the electric field intensity. Then E due to plus q charge, right side it is there, and E due to minus q charge, left side it will be there. What is the direction of the net field? What is the direction of the net field? The net field is away from positive charge, because E plus q is more, because plus q is nearer, its effect is more, distance is less, that's why electric field due to plus q charge is more, and minus q charge at long distance, that's why distance is more, means electric field is less, E minus q is less, E plus q is more. Right side electric field is more, that's left side electric field is less. When you find out the net electric field, we will get the right side, because right side field is more. That means electric field intensity on the axial line, we will get right side. That means electric field intensity on axial line, electric field intensity on axial line, on axial line. Axial line means the line passing through the two charges. Okay, is parallel to what? Parallel to P bar, right? That means EA bar parallel to P bar. That means parallel to dipole moment. That means it is in the direction of the dipole moment. That means it is in the direction that is minus q to plus q. This is the topic, that electric field intensity on the axial line of electric dipole. The formula to find out the electric field intensity on the axial line is 1 by 4 pi epsilon naught to p r by r square minus L square whole square. In case of short dipole, the formula is EA is equal 1 by 4 pi epsilon naught into 2p by r cube. Okay, and now our topic is electric field intensity on the equatorial line of dipole. Electric field intensity on equatorial line of dipole. These two topics are very important for the board exam, the derivations. And now, how to find out the electric field intensity on the equatorial line, and what is equatorial line first. Electric field intensity on equatorial line. Equatorial line. What is equatorial line? Okay, and how to find out the electric field intensity on the equatorial line? And for that, let us take two charges. Okay, and electric dipole we will take, and that is, one is minus q charge and other one is plus q charge. Next one is plus q charge, and this is we will take as A, and this is we will take as B, and this is the center, and now this distance we will take as L, and this distance we will take as L, because simply we will take the dipole length as 2L, we know already. Now here this is the line passing through the center of the dipole and perpendicular to the axial line. This is axial line, right? This is the line passing to the center of the dipole and perpendicular to the axial line, and this line is called as equatorial line. I want to find out the electric field intensity at point P on the equatorial line of electric dipole. Okay, I want to find out the electric field intensity on equatorial line at point P. At point P, I want to find out the electric field intensity that is on equatorial line, and for that electric field intensity at point P is there due to minus q charge and due to plus q charge also. Then we have to add them according to vector, because according to principle of superposition, the total electric field intensity is equal to vector sum of electric fields due to individual charges. Now I want to find out the electric field due to minus q charge. For that we can add the point P and minus q charge, and also we can add plus q charge and point P. And electric field due to minus q charge direction I want it here. Okay, here this is minus q charge, here I want the electric field direction, here I want the electric field direction. Electric field is towards negative charge, that we know already. Okay, and now this is plus q charge, and here I want the electric field intensity. Electric field intensity due to plus q charge is away. Electric field intensity due to plus q charge here I want. Okay, and that is away from positive charge, away from positive charge. Okay, here if you want away from positive charge, if you want here electric field intensity is away from positive charge. Okay, like this electric field is always away from positive charge and towards negative charge. Based on that we will write the directions at here, that is electric field due to minus q charge is towards minus q. This is E minus Q direction, and electric field is due to plus Q charge I want. This is the plus Q. This is the point P. At this point we want. This is the equatorial line. This is equatorial line. Okay, this is equatorial line. What is this? This is equatorial line. Equatorial line. Okay, and now here electric field due to plus q charge away will be there. That means this is the direction of E due to plus q charge. Okay, and E due to minus q charge will be like this there, and E due to plus q charge will be like this there. Okay, and now here we will take this angle as theta, and this angle is also will become same theta. And now I want the electric field intensity at a distance r from center of dipole. Okay, I want the electric field intensity at a distance, electric field intensity at a distance smaller from center of dipole on equatorial line. Okay, at a distance r from center of dipole on equatorial line I want the electric field intensity. For that according to mathematics, okay, and here angle theta matlab here also theta, then here theta matlab here also you will get theta. And now let us classify this electric field into components. Then for that this is E plus Q, I will clarify it here. And now this is E plus Q, and this is E minus Q. This angle is theta. I will classify the E plus Q into components like this. This is E plus Q cos theta, and this is E plus Q sin theta. This is E plus Q cos theta, and this is E plus Q sin theta. Okay, and now here what you will get, this is E plus Q, at here we will write this is E plus Q, and E plus Q this direction. In this direction what you will get, E plus Q cos theta we will get. Why? This is the component attached with the angle, that is adjacent component. Adjacent component always you will get by multiplying with cos. Another component is a vertical component, that you will get by multiplying with sin. E plus Q into sin theta. Sin theta. Okay, and now E minus Q also classified into components. This side E minus Q cos theta we will get. Okay, this is adjacent component, and this side E minus Q sin theta we will get. Okay, and now here this E minus Q is also classified into components, and this is E minus Q cos theta, and this is E minus Q sin theta. These are the components. Okay, I will tell the components again once again. This is E plus Q direction, and this is E minus Q direction. This angle is theta. I want to classify the E plus Q into components. This is E plus Q cos theta, and this is E plus Q sin theta, and this angle is E minus Q. E minus Q also classified into components: rectangular components, perpendicular components. One is this side and other is this side. Here this one is classified into components, two parts like this. This is one, and now divided into two parts. Okay, two parts. One part cos, other was sin. And here also E minus Q also divided into two parts, right? Two rectangular components, मतलब perpendicular components. E minus Q cos theta, and this one is E minus Q sin theta. Now if you see this diagram, E plus Q sin theta, E minus Q sin theta, both are in opposite direction, and E plus Q cos theta and E minus Q cos theta are along same direction. That means these two are same direction. To find out the net we have to add, but these two are in opposite direction. To find the net we have to subtract them, but they are equal in magnitude. E plus Q value, E minus Q value same. Why? Because charge E formula, E depends upon charge and distance. Charge Q, distance is also same for both. That's why E plus Q, E minus Q values are equal. That's why this component and this component are equal in opposite direction. They will cancel with each other. Out of four components, this is divided into two components. This is also divided into two components. Out of the four components, two components are cancelled with each other because they are equal in opposite direction, and some more two components are along same direction. They will not cancel with each other. To find out the net electric field at point P, we have to add these two components. Now let us start. If you add them, then we will get easily answer. And now for that we have to, from the figure we write AP square is equal to AC square plus BC square. That means AP square is what? Sum. AC square is what? AC square is L square, BC square is R square, matlab R square plus L square. BP square I want, BP square from the figure. This is a rectangle triangle. Okay, BP square is equal to what you will write? PC square plus CB square. Then again PC square is R square plus L square. This also we write first PC square. AC square, a triangle say AP square is equal to PC square plus AC square according to Pythagoras principle. PC is R square plus L square. AP square equal to BP square. Now I want the electric field due to plus Q charge. Electric field at P due to plus Q charge. Then what is that? E plus Q. Yes, what is the formula? 1 by 4 pi epsilon naught into plus Q charge Q. Now Q charge distance from point P. We want to find out the E plus Q at point P. Q charge distance from plus Q charge distance from point P. BP. Yes, R square distance square. BP square we will write. Now but BP is 1 by 4 pi epsilon naught into Q by BP square is already we know. R square plus L square. R square plus L square. Right? And now this is equation 1, and electric field due to minus Q charge I want. Electric field at P due to minus Q charge, that I am taking E minus Q. Its formula is 1 by 4 pi epsilon naught. Only magnitude I am writing. That's why you should write only q. You don't write minus q. By q distance. Q distance. What is the q distance from point P? Minus q distance from point P. That is AP. Yes. Distance square we have to write according to formula. Yes. But 1 by 4 pi epsilon naught into q by AP square from figure. R square plus L square. Yes. By this is equation 2. From equation 1 and 2, what we write? From equation 1 and equation 2, we write E plus Q is equal to E minus Q. Two are equal. Now, I want net electric field intensity. Now, to find out the net electric field intensity at point P, this E plus Q, E minus Q divided into components. Then, two components are cancelled with each other and the two more components are along same direction. Okay. And now, what you got E plus Q or E minus Q? Then we got E plus Q or is equal to E minus Q we got. Dono same. Then formula what you got? 1 by 4 pi epsilon naught into Q by R square plus L square we got from equation 1 or equation 2. Okay. And now I want the from figure we write one thing that when you divide the E plus Q into components, E plus Q cos theta, E plus Q sin theta. E plus Q divided into components, E plus Q cos theta, E plus Q sin theta. E minus Q divided into components, E minus Q cos theta, E minus Q sin theta. But E plus Q cos theta, E plus Q sin theta and E minus Q sin theta are equal and opposite. Equal and opposite. Hence they cancel with each other. Cancel with each other. Okay. E plus Q sin theta already equal. E plus Q, E minus Q values already equal. Now that's why they will cancel with each other. Net now E plus Q cos theta, E minus Q cos theta along same direction. Net electric field. Net electric field at P on equatorial line. Yes, we want to find out the net electric field on the equatorial line. Then how to find out it? That electric field intensity on the equatorial line. Two components cancel out of here. E plus Q divided into two components. E minus Q divided into two components. Total 4 components. Out of that 2 components cancel. 2 components are in the same direction. That we have to add them. Then E plus Q cos theta plus E minus Q cos theta. But here we know E plus Q equal to E minus Q or E minus Q equal to E plus Q. This plus Q is not E into plus Q. It is E suffix plus Q. मतलब electric field due to plus Q charge. E suffix minus Q मतलब electric field due to minus Q charge. Now here we write E plus Q, E minus Q also E plus Q we write, or E plus Q also E minus Q we write. If you write here E minus Q cos theta, this is also E minus Q cos theta, then what you will get? E minus Q cos theta plus E minus Q cos theta. From this equation we will get this one. Okay, E plus Q equal to E minus Q. Then we will get 2 into E minus Q cos theta. Now net electric field intensity on the equatorial line is 2 into E minus Q cos theta. Yes, we know from equation 2 E minus Q. From figure I want to, from triangle APC, then cos theta formula I want to write. Cos theta is adjacent side by hypotenuse, AC by hypotenuse is AP. Then we will get AC is L by AP is under root of R square plus AP square. Already we know AP is under root R square plus L square. Pythagoras principle according to that, R square plus L square. Then we substitute in above equation all the equations, that is E on equatorial line is 2 into E due to minus Q charge is what? 1 by 4 pi epsilon naught into Q by R square plus L square, that we derived already, and that is from equation 2 we write this one. and cos theta is here we got L by under root of R square plus L square, and finally we will get one formula, that is E on equatorial line is 1 by 4 pi epsilon naught into Q into 2L by, this one is R square plus L square, this one is R square plus L square whole power 1 by 2. Okay, this is R square plus L square, and this is R square plus L square whole power 1 by 2. When we will add the base same होते तो a power m into a power n we write as a power m plus n. Like that here R square plus L square whole power 1 plus 1 by 2 we will write, that is R square plus L square whole power 1 plus 1 by 2 we will get as R plus R square plus L square whole power 3 by 2. And now this is E on equatorial line is 1 by 4 pi epsilon naught into, this one is Q into 2L is P, we know already, that is P by R square plus L square whole power 3 by 2. This is the formula for the electric field intensity on the equatorial line. Okay, electric field intensity on the equatorial line. The formula is 1 by 4 pi epsilon naught P by R square plus L square whole power 3 by 2. You have to remember this formula, electric field intensity on the axial line and electric field intensity on the equatorial line. And now, in case of short dipole, in this also we have to take the case that in case of short dipole, how we can write the formula. In case of short dipole, yes, short dipole matlab length is very much less comparing with R, then L can be neglected. When we neglect the L, then what happens to the formula? Then electric field intensity on the equatorial line we will get as 1 by 4 pi epsilon naught into P by, this L we write as 0, R square plus 0 square is R square whole power 3 by 2. Then this one, how it will be changes? When you write L as 0, L can be neglected, matlab L nearly we write as 0. Then when L you will write the 0, then we will get R square whole power 3 by 2, these two cancel. Finally we will get electric field intensity on the equatorial line as 1 by 4 pi epsilon naught into P by R. This is for only short dipole. Short dipole means whose length is very much less comparing to the distance of the point where we are finding the electric field. And now finally direction we want, direction of E on equatorial line, direction of electric field intensity, direction of E on equatorial line. Yes, direction of E on equatorial line. Then for that, this is minus Q charge and this is plus Q charge. At a distance R, I want to find out the electric field on the equatorial line. At this point, electric field intensity we find out that is along this direction. Okay, and dipole moment direction what? Minus Q2 plus Q. And electric field on the equatorial line we got this direction because vertical components are cancelled with each other. Only horizontal left side components will be remains. That means E on equatorial line, electric field intensity at a point, at a distance smaller from, at a point we will get, at a point on equatorial line is anti-parallel, we will write, anti-parallel to electric dipole moment, okay, and E on equatorial line is anti-parallel to dipole moment. Why? Electric field we got right side, left side, but dipole moment right side minus Q2 plus Q. That means electric field intensity on the equatorial line we got anti-parallel to the dipole moment, okay. But electric field intensity on the axial line it is parallel to dipole moment, but electric field intensity on the equatorial line it is anti-parallel to the dipole moment, okay. And we derived finally in this class, okay, we discussed about what is electric dipole and what are the formulas to find out the electric field intensity on the axial line and on the equatorial line. Now first electric field intensity on the axial line, what is the formula we got? Okay, electric field intensity in case of short dipole, I want the relation between the electric field intensity on the axial line and equatorial line. In case of short dipole, relation between EA electric field intensity on the axial line, E on equatorial line, this relation I want. And for that, on axial line, yes, we know axial line formula. On axial line, what is the formula to find out the electric field intensity in case of short dipole? 1 by 4 pi epsilon naught into 2p by r cube. What is r in this? P means dipole moment, okay. R is what? Distance of point. Okay, distance of point where we are finding electric field. From center of dipole. Okay, and for example, this is minus q charge and this is plus q charge, and this is the center, and this is axial line. Here I want to find out the E on axial line at point P, and their distance is r, distance of point P where we are finding the electric field from center of dipole. Okay, and now on equatorial line, what you will write? Equatorial line, what is the formula? Equatorial line, electric field intensity on the equatorial line formula is 1 by 4 pi epsilon naught, we derived just now. In case of short dipole, P by r cube. Okay, and this is equation 1 and this is equation 2. And here the electric field intensity on the equatorial line, this is minus q and this is plus q. From center of the dipole at a distance r, electric field intensity on the equatorial line in case of short dipole is 1 by 4 pi epsilon p by r cube. Normal formula what? 1 by 4 pi epsilon. In case of short dipole short nahi hote to, then the formula is 1 by 4 pi epsilon p by r square plus l square whole power 3 by 2. Here in case of short dipole, this formula. Other one okay, electric field intensity on the axial line in case of short dipole, this is the formula. But if it is not short dipole, the general formula is what? 1 by 4 pi epsilon to 2p r by r square minus l square whole square, that we derived previously. And from equation 1 and 2 directly we will write the relation between the equation 1 and equation 2, that is E on axial line and E on equatorial line. Anybody? Yes. EA is 2 into remaining is what? 1 by 4 epsilon p by r cube. Remaining is E on equatorial line. That means we will get E on axial line is equal to 2 times of E on equatorial line. This formula is applicable for only short dipole, but for the other normal dipole it is not applicable. Okay, now okay, if you like my channel, then you can subscribe and share to your friends. Thank you for listening and subscribing, share and comment my channel.